how do you go about testing a fuel cell system? How do you know whether it's reliable, what the performance is, and all these things? I'm standing here on the roof of a testing facility. This is the exhaust of a fuel cell system. You can see the stuff coming right out here. My hands are all getting wet. That's one end. Also very important, the cooling of the system. Over here, you can see it. That's the fan blowing out the air from the entire system. I'm going inside now to go and meet Katia. She's a chemical engineer, has been running this facility for quite some time, works for Nuvera, and she's going to tell us all about this. Join me. Katia! Hey!
Steven,
how are you?
Well, fine, you?
Great, thanks for having us. Katia, what is it exactly that you do here?
Here we test our product. In particular, this is our engine test module where we can test 8 E45 or E60 modules, meaning that each of them has a power of 45-60 kilowatt power.
Okay, so you can test 8 of them, meaning one here, one there, and this is in the entire container. So we have 2 over there, we see 2 here, 2 more over there and over there.
Yes.
And these can be running in parallel.
Yes, they are working all in parallel or in an independent way, all continuously.
So that actually was the, I would say, quite an interesting part, because we came here and literally you were the only one that opened the door for us, and this was all running. So this is all like running on its own.
Yes.
Okay, so tell us, Katia, how do you actually test the fuel cell system? I mean, you know, it's one thing getting one here, but now you want to actually test it. What do you need to make a test system like this work?
Okay, basically for getting the power from this system, we need to supply hydrogen.
Hydrogen, so you have a hydrogen supply. Can you show us that?
This is the hydrogen supply line.
That's over there, right?
Here you see the hydrogen pressure.
What are we doing now? 12 bar
13
there.
Yes, between 12 and 13 bar, exactly.
Yes.
And then you need air. Here you see.
Oh, that's the air filter there,
yes,
right? That's
exactly.
sucking in air from the environment, like that.
Exactly.
Okay, right.
And in fact, this is an important point because here we are in an industrial area.
Yeah.
So the air is polluted, and so it's important to have a filter in.
Right.
As in the real application, we need to have a filter inside.
Understood. So air in, hydrogen in. Where's the exhaust?
Okay, so you need to look in the top.
Oh yeah, that was where I was. That was where I was standing before, right on the top there. Yeah. So that goes this way down here, and then to here.
Yes, exactly.
So this system is actually running now and sending the exhaust all the way up.
On the top.
Okay, what happens here?
Basically, here is a water separator.
Right.
So we condense the water coming out from the stream.
Yeah.
And so removing the liquid water just to better evacuate the exhaust.
Okay, and I mean we know that these are your systems. What do you have down there? What are these things?
Okay, basically you know that the fuel cell system generates electricity, but also heat.
Yes.
So we need to remove the heat. We do it in 2 ways. Then there is on the top, there is a radiator that dissipates most of the power. When we run some specific test, we need to increase the capacity of cooling down, and so we have added also some heat exchanger for the composer.
So you've got the air cycle, you've got the hydro cycle, and you've got the cooling cycle. So basically, this is part of your cooling cycle, and you can. So you have cooling with the radiators on the roof. Okay, and those are heat exchangers for that cooling.
Exactly.
Okay. So the hydrogen supply, that's a really interesting point. Where do you actually get the hydrogen from?
Yeah, we are inside the company, but it's a gas producer. Here it's produced the hydrogen that we use for our testing.
Okay. So actually, guys, I need to tell you, we are actually inside the gas facility here. We went through the whole security and ID check to come here. Thank you for opening us. But so they make the hydrogen, and where's the pipe that you guys then actually get the hydrogen from?
Yeah, so basically it's produced on their plant.
On the plant
and
here,
then
yeah.
it comes here. You see,
Okay.
this is the
It
main
comes through
pipes,
this red pipe here, okay.
exactly where we get the hydrogen, and then if you follow.
So if I turn off here.
Yes, this is a turn-off
So
valve. So
don't touch.
don't touch, don't turn off.
Okay.
Absolutely. So we don't get any more hydrogen for our testing. And then here you can follow our line. Here you have a hydrogen pressure regulator to decrease the pressure because we receive a high pressure like in the bottles.
Okay, so they send you with 200 bar or something like that.
Yes,
Okay,
exactly.
I like that.
And we reduce at the level that it's needed for our testing,
Yes.
that it's around, as you see before, 12, 15 bar.
Yeah.
Then you follow it, there is a pressure relief valve.
All right.
So in case there
For
is an
safety.
excess of pressure, it's important for safety to release it. And then you go on, you follow the pipes over there, and then here it's go in the ground, and you can follow at there. It's the main entrance of the hydrogen in the engine test module. You
Perfect.
see?
So
Okay.
it pops into your container.
Yes,
right
and there it's distributed in each individual engine.
Yeah. So, okay, now we've seen the system, and obviously we saw the supply there, safety valve there. Can we take a moment and talk a little bit about safety? So,
Okay.
what do you do to make this safe? You know, like how do you factor that in?
Basically, safety is very important, and as you know, where there is hydrogen, we need to consider safety. And in the engine test module, we did adding some hydrogen sensor inside,
Okay.
since the container is closed.
Okay, so these containers are actually normally closed.
Yes.
Yeah. And you have hydrogen sensors in there
Yeah,
that are monitoring
continuously.
hydrogen concentration inside.
Exactly.
Yeah.
This is one of the features for safety we have inside, but
Okay.
it's not the most important part.
Not the most important?
The most important is the ventilation.
Ventilation.
Because you need to prevent in any way that there is the formation of an explosive atmosphere. And to do that, you need to ventilate. Ventilation is assured with a fan that extracts the air that is inside.
Okay, I think we're gonna go inside now and take a look at the fan and the sensor. Okay.
Please go in. While entering, please take a look of the hydrogen sensor we were talking before. And then just in this direction, you see the fan.
That's the big fan there. Oh yeah. And you can, I can see your hair.
You see there is a lot of air coming through. So, ventilation.
That's real
is-
ventilation. Actually, I can even feel it even as I stand here now.
So ventilation is the primary way in which we get a safety environment. You need to prevent any explosive atmosphere, and this is the main reason to have a fan in.
Okay, Katia, so let's go inside and talk a little bit about the actual testing process after we've seen this now.
Yeah.
Maybe as we go, the hydrogen that you use here, is this green hydrogen?
No, it's not green, but it's a blue hydrogen.
Blue hydrogen, okay. What does
Yeah.
that mean?
This means that hydrogen is produced from a conventional methane
Yeah.
gas, but the carbon dioxide that is produced in the process is not vented in the atmosphere, but it's captured, and it's a product as well,
And
so
reused.
we can use it.
Okay, perfect, okay. And the second question is, I know you run these systems here and you generate a lot of power. What do you do with the power?
Yes, you are right. You know that our system produces DC power.
Yes.
Then engine test module has some inverter
Yeah.
to convert DC power in AC power.
Yeah.
And that's the power going into the grid.
Into the grid. Ah, okay, so you put that back here. Perfect. Thanks for explaining that, Katia. Let's go
You're
inside
welcome.
your setup room
Okay.
and talk about the actual test process.
Absolutely. Please come in.
So, I know this is your setup room where you prepare all the things that you put over there, and the E45 system we've seen already. But
Yeah.
here is also some new stuff which no one has seen before.
Yeah, have you seen it? I'm very excited because it's new.
Okay.
We just received it. It's a new proof of concept of a 125 kilowatt system we are developing.
Okay, so they are busy setting up a new system. I guess we will talk about this separately at some time, so let's
Yeah.
not focus on this too much yet. It's a pre-phase of a product Nuvera is putting together, 125 kilowatt,
Yeah.
and we'll be excited to talk about it. But now focus on the actual testing, and you tell us about reliability.
Yes, of course.
So Katia, tell me, reliability, how do you actually test and say a system is reliable?
Yeah, good question and very important. So we define a test plan in
Yes.
terms of reliability growth, focusing the attention of the load profile of the final application of a product.
Okay, so you get a load profile of the final application. Where do
Yeah.
you get that load profile?
We analyze the different sector of application because there is maybe not one, but
Okay.
different one,
Yeah.
and each of them has different power needs.
Yes.
So we combined in a final load profile that it's a combination of
Okay.
all the needs.
Stick it together,
of
make a
the-
nice load profile. Okay, and
Yes.
then you run it 1,000 times, or how do you do it?
So we run for an extended period of time, and for example, for the product we have seen before, so the E45, E60, we accumulated 37,000 hours of running.
Oh wow, 37,000 hours running on that system outside
Yeah,
there.
and in fact, we decided not to do on one system alone. We did on engine test module for the specific reason to be able to have multiple systems running at the same
At the
time.
same time. All right, okay,
And
I like
this
that.
is important to have reliable and consistent results
Exactly,
as
and
well.
you get more data, exactly.
And more-
Yeah. So Katia, how do you ensure consistency, that the tests you do on the 1st of April is similar to the one you do on the 1st of September?
Yes, to do that, we maintain our equipment calibrated. So there is 2 points to say. The first one is that for specific engine test module, we add extra sensor. So for taking one measurement, for example, temperature of the coolant,
Yeah.
we don't use just one sensor, but two.
Okay.
One is the sensor of the product, and the other one is the sensor of the test bay, so
okay,
the
so you
engine
have
test
extra
module.
sensors in there.
So using redundancy and calibrating one of them, we are sure that the measure is really reliable and we can count on
On
what
that.
we are measuring.
Yeah. Yeah, because you have it outside there and so on, things can change. Tell us, when you get a new system, how do you actually start this whole process, and how does it look when you get going?
Yes, okay. It's a part of the process of qualification of our product.
Yeah.
You know that our product is built in USA.
Ah, okay.
So we get it,
get it,
and when you get it, the first things we do is to check performance. So in our factory, they already did a preliminary, what you call factory acceptance test.
Yes.
So basically, we repeat it.
Oh, okay.
And this is the important step to assure again that the product has consistent results. So you need to test and verify that the performance is exactly the same, unless you have not a good quality of your
Understood.
product.
Can you show us how that looks? Yeah.
Absolutely. To do it,
Yes.
basically, there is a power check level,
Yes.
meaning that we change the power. We start from low power,
Okay.
medium power,
So we see
and
that
high
here.
power that we see here in this graph.
Yeah.
And while you are starting increasing the power, you observed a decreasing in the voltage and an increasing of the current as
So
well.
we start at 0 and the power
Yes,
is the
you
blue,
start at
the
zero,
dark
the
blue
power
up.
is the blue,
Yep,
from
and then, yep.
minimum, medium and
And
maximum.
then the current is the gray,
Gray.
and then the orange is the voltage. So there
Yeah,
you run the max
Yes,
power for some time and see how
absolutely.
how
The
stable it is.
criteria is a focus of the maximum power
Yeah.
because it's what we need to prove that
Okay.
it's reached
So that-
and confirming
That
it.
it's running consistently at max power.
Yes,
Okay.
absolutely.
And then you keep that running for a while, and then you what
Step
happens
down
next?
again and you repeat. So
Okay.
this is done a couple of times just for consistency of the two
Okay,
results.
and then you're all
itself.
set to go for more testing.
Yeah.
Okay.
And then it's one of the tests that we are doing.
Yeah. Well, we're in the lab. This is not in the lab in your actual test facility. Is this an
Yes.
alarm?
No, it's just the ringing of the phone.
Ah, this is the phone.
Yes.
Okay. Katia, outside we saw the E45 or the test stand. Test stand running is fine. Where can we actually see these systems in operation? Do they even work anywhere currently as we speak?
Absolutely, yes.
Ah.
We have some application both in USA and in Europe and in China.
Okay.
But focusing on Europe, where we are.
Yeah.
So there are some application in material handling equipment.
Okay.
So
We
for
see them here.
example, we see a reach stacker
Ah, right.
and
So
a top
the
loader.
Containers and so on. Okay.
Absolutely.
So-
That,
So we're talking heavier material handling kind of
yeah.
applications. Okay.
Yes, and again, a terminal tractor is a similar application. And we have a bus, this is in India.
Okay.
And this is a prototype car in UK.
Ah,
and
for racing?
Yeah, exactly. Soon
Right.
there is a fair and then
Okay,
they
you
will
will see
show
that.
it.
Ah, right. Okay, so a bit of it here. And then the, you see you have in the marine as well, you have them.
Yeah, we have some application in the marine because we know that marine is an environment very polluted, and so we hope that having some clean product we can improve the life.
So that's a good point to get to the outlook of this whole thing. Marine, I think, is going to be even bigger. Katia, can you give us a bit of an outlook of testing? You know, what are you guys thinking of doing here, and how do you see this whole testing going in the next years?
Yes, here, as you see, the main focus is to test the product.
Yes.
And we have bigger product to test.
Yes, yes, yes. We saw some of it already. Yeah. So you'll be very busy with that. Yeah.
Exactly. So we will maintain active testing in terms of reliability of a future product that we need to prove before being on the field. And a lot of activities of also qualification new material. So the path, of course, is both on developing new stack and new material inside the stack to extend the stack lifetime.
Oh, wow. Okay, so that means bigger systems coming, more materials, and obviously getting all those things reliable. And that's what you and your team are doing here.
Yeah.
Katia, thank you so much. This has been an absolute pleasure for you having us here, showing us all this stuff. I think everyone understands now more or less how one can test a fuel cell system. I think there's a lot that goes into it. So even if you try this at home, well, maybe talk to Katia first.
Thank you. It has been a pleasure to have you and those videos.
Well, thank you. And I hope that if you enjoyed the video, you give us a like. We've got many more videos. Actually, we also have a video on the E45 system where your colleague shows us more about that. And maybe we can even do a video soon about the bigger system, which we saw a teaser of. Thank you very much for watching. Follow us on Hyfindr and get to meet people like Katia and more exciting products for the hydrogen industry. Thank you very much.
Thank you. Thank you.